237, couple things I want you to highlight, and we'll add a couple of notes to this. Now, what we're looking at in 3.5 is the inverse function. The inverse function is what undoes the regular function. So, what's the opposite of adding 2? Well, I'd have to subtract 2 to undo what I did. Graphically, the inverse function is reflecting over the line y equals x. So what I want you to do off to the side is we're going to make some notes both about things graphically and algebraically. Graphically, if you have one graph and you want to find the other graph, you have to reflect over the diagonal line y equals x. What this does is you switch your x and y coordinates. In other words, if you had the point x comma y, it now becomes y comma x. The x coordinate becomes your y coordinate becomes your x coordinate. So if you have one graph, you can find the other graph by switching the x and the y, switching the coordinates, reflecting diagonally over the line y equals x. Algebraically, because we're also going to be looking at inverses algebraically, to find the equation of an inverse algebraically, we're also going to algebraically switch the x and the y values, and then 2, we're going to get the y value by itself, which is the thing that we did yesterday in the getting started. So our first couple of examples, one is going to look at things graphically first and then algebraically. The other one's going to look at it algebraically first and then graphically. Everybody good? So, for example 1, example 1 starts with it graphically. So if we want to sketch the inverse, what we're going to do, I'm going to take out a red pen here and draw a diagonal line and label it y equals x. We want to flip our graph over that diagonal line. Sometimes it's hard for our brains to actually flip something diagonally. It's much easier for our brains to flip it horizontally or vertically. Flipping diagonally is a little bit tricky. So the other note that we wrote for graphically is that any point that you have, so for example, here I have -4, 4. On the inverse, you're going to switch the x and the y coordinates. So if I have -4, 4, and I switch them, can you see that you would now have 4, -4? This point, -1, -1, when I switch them, well, it's still going to be -1, -1. This point up here, which is at 1, 3, is now at 3, 1. And finally, the point that was at 3, 2 would now be at 2, 3. So graphically, if you have coordinates and you just switch them, that becomes really easy. Now, when I connect the dots, I have to be careful that I connect them in the right direction. And one thing that examiners, when there was a provincial exam, sometimes look at is they would look at, do the two graphs intersect correctly on that diagonal line? Because when a point is on that diagonal line, like -1, -1, and you switch x and y, it's still going to be the same point. So any point on that diagonal line is going to stay the same. As far as mentally reflecting over a diagonal line, you are perfectly allowed to do this on a test. It's not cheating. Well, it's not officially cheating. But you take your paper and you turn it. If you turn your paper so this becomes a horizontal line, then look at it. It's much easier to see that reflection. Because maybe some of you are good at this brain-wise. Can you see that the red one flipped over that dotted line is the blue one? But if you turn your page a little bit and then flip it, you can see it much better. Make it a vertical line for you. And your brain goes, yes, I like that a lot better. The diagonal one is kind of, your brain has to work harder. Right? So I'll notice on the test, it'll be like, oh, changing it. That's perfectly fine. Okay? So, now, part B. Is the inverse a function? The answer to that is no. Why? Do you remember the vertical line test? In previous years, you were able to check if something was a function with the vertical line test. The way the vertical line test works is if you move the vertical line across, and that vertical line ever hit the graph in more than one place. Right now, can you see the black line hits the blue graph in 2 places? If it hits it in more than one place, it is not a function. So the red graph, look at the red graph. The red graph is a function because as I go across, it only hits the red graph at one point no matter where I am. But for the blue one, I can find a spot where it hits more than one point. So now, if I was explaining, is this a function, explain, it does not pass the vertical line test. Which means there are some x values that have more than one y value. There are some x values that have more than one y value. When we have a function, we want like x squared as a function. If you plug in 2, you get 4. When you plug in 3, 3 squared is 9. You want to always have one answer. If you had a calculator that all of a sudden gave you different answers, you'd be like, what's 2 plus 2? 7. Let's try that again. 2 plus 2. 4. Something's not working. It's not giving me the same number every time. We actually, in the English language, we would say it's not functioning. When something's not working, we sometimes say it's not functioning. That's kind of a connection to math. For a function to work, you plug in an x value, you only get one y value. If you get more than one y value, we say it's not a function. We can test that simply with the vertical line test. As soon as I hit 2 y values with that vertical line, I know it's not a function. State the domain and range of each one. So, for my domain, do I have a smallest x value? Yes, -4. Do I have a biggest x value? +3. For my range, do I have a smallest y value? -1. Biggest y value? +4. Then for my blue graph, domain and range, do I have a smallest x value now? -1. Biggest x value? +4. And smallest y value? -4. Biggest y value? +3. And now I want to point out the common theme that's both algebraically and graphically also shows up with domain and range. The common theme is that the x and the y are getting switched. Graphically, we took the coordinates and switched them. algebraically, we're going to actually take the variables and switch them. And if you switch your x and y values, does it make sense that your x values, your domain, becomes your range? And your range becomes your domain. That's also this idea of your x and y values just switching. So if my domain is my x values, on my inverse, that would be my range. Okay, questions to circle for this one are 4 and 9.